Hey guys, here we are. I'm going through test 4, organic and biological chemistry. Look, I'm going to go through most of the tests just to sort of help you understand where you might have made mistakes and stuff like that. So if we look here at question 1, this was a really simple one. Look, I think I put a dash in there when I wrote. But look, really easy. This is all stuff that you should have done in year 11. So 2-methylbutane, obviously your longest carbon chain is butane. So put those in there, and on the second carbon chain you put your methyl. Now in a normal test you'd make sure there are H's at the end, but just to make this a bit quicker, I'm not going to put the H's on. So really simple one, year 11, should have got it easy. So methyl propanoate is an ester, okay, there's my side chain and there's my main chain. So prop being 3, there's my main chain, okay, put in my ester link, and then I put in my side chain, so CH3. Again, make sure on these bonds you put the hydrogens, but for the sake of this, I'm not going to worry about it. Butane 1-amine means I've got a butane molecule, which is 4 carbons, and I've got an amine on the end. Okay, and propan 1,2-diol. Okay, propan is 3 carbons, 1, 2, 3, and 1,2-diol means I'd have 2 hydroxy groups on the first and second carbon. Again, finish off with your H's. So 4 really easy marks there. You sort of go on a mark a minute. You should have done that question. We've just been speaking for less than 2 minutes, okay? And we've already got them all out there. So draw the structural formula of the following 2 molecules, ethanol and ethanal. Well, they've basically both got 2 carbons, okay? Except ethanol will have an alcohol on the end of it, and ethanal has a carbonyl group and a hydrogen, making it the aldehyde functional group. Okay, again, really easy. It says compare the boiling points of the 2 molecules and explain the differences observed. Okay, so looking through here, you'd have to say that they're both small molecules. All right, and you would expect them to both have high boiling points. Okay, and this is because of the hydrogen bonding that can occur here. So here we have hydrogen sites for bonding. Here we only have, so I would say, but even though they're both polar molecules, okay, we have a lot more hydrogen bonding happening at the hydroxy group. So the alcohol would have a higher BP, okay, due to hydrogen bonding. All right, this could the aldehyde could hydrogen bond to water through a hydrogen here. However, with the hydroxy group here, if I was to redraw this in its proper bond shape, okay, we could get, if we were dissolving in water, this is what would happen here. So, and even though I've said about boiling point, the reason why I'm using water here is because you can see hydrogen bonding occurs a lot more than what it does in ethanol than what it does in ethanol. So you wouldn't put water on there, but you would say that because of hydrogen bonding, ethanol would have a higher boiling point. All right, moving on, question 2, all right? When I see this type of question with a lot of molecules, I straight away look for what the functional groups. So here, even before the questions are, so here I know I have a primary alcohol, all right? And that's because of the OH on the end here. All right, I know here I have an aldehyde, because again, I have that functional group. Here I have a carboxylic acid, because of the COOH functional group on the end here. All right, and here I have a tertiary alcohol. So before the question's even asked, I'd be looking at what do I know. So primary alcohol, the different tests I could use obviously are dichromate. The aldehyde I could use dichromate, and I could also use Tollens, or I could use Fehling's. All right, the carboxylic acid test, I'd be looking for acid base. Okay, acid carbonate, or even acid metal reactions. And the cool thing is about tertiary alcohols, I'd be looking for no reaction whatsoever. So I really wouldn't be worried about this one. All right. Anyhow, it says here the student tested a sample from each bottle with the following reactants: 20 mils of ethanol and 5 mils of concentrated sulfuric acid. All right, acidified potassium dichromate solution and Tollens reagent. All right, let's explain how the tests outlined above can be used to distinguish features of the 5 molecules above in your response, including observations resulting from each test. So if I look at the 20 mil of ethanol plus 5 mil of conc H2SO4, well, will a primary alcohol react with another primary alcohol? The answer is no. Will an aldehyde react with an alcohol? The answer is no. Will a carboxylic react with an alcohol? The answer is yes. All right, a carboxylic acid is what we call esterification. So my carb acid plus my alcohol, okay, is esterification. And what would I expect? What would the observations be? Okay, will it actually be a fruity smell? All right, that's what you would get with your reaction there, a fruity smell. So straight away by using that first test, we could tell what the carb acid was. All right, so that would take out part C. Our second test was acidified potassium dichromate. All right, so let's have a look here then. If I add acidified potassium dichromate, that is an oxidizing agent, okay, and it oxidizes alcohols. Certain types of alcohols, my primary and my secondary alcohols. All right, and it also oxidizes aldehydes. Okay, so if we look at this test, we would have color change, and obviously we all know the color change is from orange to green. All right, once we've got that color change, so that would tell us then, that would help us distinguish that D would have no reaction. Okay, why would D have no reaction? Because it's a tertiary alcohol. We don't have to worry about C because we already know that's an ester, so we've taken it away. All right, and the last test is Tollens. And we know that Tollens reagent only, again, is an oxidizing agent, but it only reacts with an aldehyde. And we get a silver mirror from it. All right, so obviously we've already established C, we've established D. We've got to separate A and B. Obviously B being the aldehyde will react, so therefore B will form a silver mirror. And A is your primary alcohol. Okay, so again, using the tests, you're able to distinguish between these four chemicals just here. All right, question 2 said cortisol is a hormone that is released during starvation. It stimulates the production of glucose to form protein. The structures of cortisol and glucose are shown below. So name the functional group circled. All right, that's carbonyl. That's a carbonyl functional group. I will accept ketone as well, and so will your examiners. All right, and number 2 here is the aldehyde. Again, worth 2 marks. If you're basing on a mark a minute, that should have taken you 30 seconds. You've just freed up a minute and a half later on somewhere else. It then says circle the hydroxy groups in cortisol and label whether they're primary, secondary, or tertiary. So here's this is a primary alcohol because the alcohol, sorry, I was mistaken there. All right, this alcohol here is attached to a carbon which is attached to 2 other carbons, so 1, 2. So this is a secondary alcohol. This one here is attached to, so my hydroxy is attached to a carbon which is attached to 1, 2, 3 other carbons, so that's a tertiary. All right, and I'll just draw those in there, 1, 2, 3 other carbons, and this alcohol group here is attached to my carbon which is only attached to 1 other carbon, so that's a primary alcohol. All right, this was worth 3 marks, so you'd sort of expect you'd have to mark 3 alcohols in there. All right, so give 2 reasons why alcohol can be classified as a carbohydrate. All right, well, first of all, we know a carbohydrate because it fits a general formula. All right, so let's just write down the glucose formula C6H12O6 here, and we know that a carbohydrate fits the form CxH2OY, which in this case is C6H2O6, which equals C6H12O6. Okay. The other thing too, it's another way is a carbohydrate we call a polyhydroxy. Okay, polyhydroxy hydrocarbon, in which case glucose is. Polyhydroxy means many hydroxyl groups, so 1, 2, 3, 4, 5 there. All right, and this is still a hydrocarbon. So they're the two reasons why. Okay, it says glucose is used by yeast during fermentation. Write a balanced equation for the fermentation of glucose. This here, guys, is a stage 1 thing. So if you don't know it, review your stage 1 notes. I'm not going to go over it again, or look it up on Google. Okay, so I've got C6H12O6. All right, we have yeast, and we also have a temperature of about 32 to 37 degrees. All right, and we get ethanol here, C2H5OH, plus carbon dioxide. All right, and just balance that equation out. Again, 2 marks. That should take you less than 2 minutes. You should be smashing it out. It says here, some cortisol is heated with acidified potassium dichromate solution. It says, draw the structural formula of one organic product expected from this reaction. Okay, so again, they give you big structures, all right? You don't look at the big structures, just look at the functional groups. So if we find it here, I've got a functional group here. Okay, so if we look at it, I've got a functional group here, I've got a functional group here, a functional group here, 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 and here, believe it or not. So really, when I look at this structure, I've got 1, 2, 3, 4, 5, 6 things I need to worry about. That's it, okay? What does acidified potassium dichromate solution react with? Well, we know acidified potassium dichromate solution only reacts with primary, let me get this right, primary and secondary alcohols. Okay, so we know this here is a secondary alcohol from before. We know that's a primary alcohol. This here is a tertiary, so there will be no reaction. So really, all that's going to change is this will change to an aldehyde group. Okay, and this will change to a ketone group. That's it. All right, so when you draw your structure up, it's going to be exactly the same as what it was before. So if I just give a real quick crude type structure here, it helps helps you guys out. All right, there's a 5-sided ring there. All right, that carbonyl group's not going to change. Okay, let's just get this right. Beautiful. All right, so if I look at my sites here, again, my ketone doesn't change. As I said, this is going to react and this is going to react. So that's going to now form a ketone, so I'll put an O there. And this CH2 is now going to become an aldehyde group. That's it. That's all you have to change. So 2 parts, again, 2 marks. Look at how much it's worth to how many groups are going to need to change. In the end, they try and make this look really big, okay, to try and trick you, but just check out your functional groups, all right? So really make the molecule actually a small molecule by only looking at functional groups rather than anything else. All right, complete the following half equation for the reaction of dichromate ions. This is what you did last topic, all right? It's a bit of revision. So how do we do it? 1, we balance the main species. Okay, which in this case here is the chromium. I have 2 on this side, so I need to put a 2 here. Then 2. We balance the oxygens with water. Okay, so I have 7 oxygens, so I need 7 H2Os. Okay, 3. We balance hydrogen with H+. So again, I have 14 H+ on this side, so I need 14 H+ on this side. And number 4, we balance the charge. Alright, so on this side here, I have 2 minus and 14 plus, which makes 12 plus. Okay, and on this side here, I have 6 plus. So what do I need to do to get from 12 to 6? I need to add 6 electrons on this side. Alright, that's balanced there. This again is revision, and it will show up over and over again. I guarantee you will have a half equation in your exam. Alright. It says here, many household substances contain linoleic acids, contain acids. Lactic acid is found in yogurt and has a formula which is right there. Draw the structural formula. Again, just it's not hard. Just draw out what you see. So I see a C with a H here. Now you have CHOH, okay, meaning you've got a H coming off the carbon, and you also have a hydroxy group coming off, all right? And then we have our carboxylic acid group, which is COOH, so OH there, all right, and that's what it looks like there. It says baking soda, okay, is used as a raising agent in agent foods to make the texture lighter. Write an equation for the reaction between the acid shown above and baking soda. Well, we have an acid and we have soda, which is a bicarbonate, and an acid and a bicarbonate. We get carbon dioxide, water, and the salt. Now, because this is a carboxylic acid, I'm going to get a carboxylate salt here. So let's look at our acid, which is CH3CHOH, plus my sodium bicarbonate. Alright, so that's going to go to carbon dioxide, water, alright, and the way to look at what's left over here is just to remove the carbon dioxide, which would be the CO2, plus one more for the water, we get rid of the 3, and I'm going to get rid of my 2 H's there for the H2O. So CO2 and H2O there, what's left over? My lovely little carbonate react, I'm going to have my what's left of my carboxylic acid, or the main part of my carboxylate salt, and I'm going to get CH3, CHOH, COO minus, and I've got sodium left over here, Na plus. So here's my sodium, here's my carboxylate salt. Again, notice how they try and get you with a big giant hydrocarbon. You're not worried about the whole hydrocarbon. All you're worried about is the bit on the end, the little functional group, all right? So make sure that just because you see a big compound, you do not get upset with it, all right?